Okay, I'm going to walk through 2A on this reflection, and you are given a polynomial right here, and you are also told that x plus 3 is a factor, and you are finding the remaining solutions. All right, so in order to do that, the first thing we have to do is divide, and I'm going to use box method. So I've got 3 vertical lines. I'm told that this is a factor, so it should work out nicely. I should have no remainder. I like to line up my terms down here so I can have like terms on my diagonal. And now we're going to do some long division. And the reason we're doing long division is because we don't know how to solve a polynomial like that. But if we divide the factor out, we're left with a quadratic, and we do know how to solve a quadratic. So we're going to do the long division. We've got 5x cubed. That's always our starting position. I asked myself, what did I multiply x by to get 5x cubed? That would be 5x squared. Now I can do my row and my column. I get 15x squared. Now I'm going to subtract to find my diagonal. 25 minus 15, that gives me 10x squared. And then I start the process over again. What did I multiply x by to get 10x squared? That would be 10x. And then I can multiply my row and my column. I end up with 30x. And again, I'm going to find my diagonal here by subtracting. 40 minus 30, I get 10x. And one more time, x times what gives me 10x? So it would be 10. And my row times my column gives me 30. So before you move on, you definitely want to make sure that you have no remainder. If you have a remainder here, that should be an indication to you that something went wrong. Either you named your factor incorrectly, in this case they were given to us, so that should be okay, or you had some kind of sign error on the inside. Okay, this still isn't my answer yet, but what I do want is this, because I do know how to solve that. I know I can name A is 5, B is 10, and C is 10. And I'm going to put this into my quadratic formula. So I'm trying to find the other solutions. This will give me my x values. Those are the remaining solutions. So I've got the opposite of 10, plus and minus. And again, the quadratic formula is on the back of your bookmark with the perfect squares on it. We've got 10 squared minus 4 times 5 times 10. So you're probably noticing at this point that this problem takes a lot of work. You could not have gotten the answer to this problem without doing all of this work. Okay, and then on the bottom, I'm going to multiply 2 times a, which is 5. Okay, so I'm going to simplify on the next line. I've got negative 10 plus and minus. I like to set all this up. This gives me 10 on the bottom. And I'm just going to put this part in my calculator. Just this part. And when I put it in my calculator, I'm going to get negative 100. So as soon as you say a negative, that should indicate to you that you're going to have an I in your answer, which means you're going to have, it's going to be imaginary. And I'm noticing that I have a perfect square under here. It's 100. So when I simplify on the next line, I've got negative 10 plus or minus, and this is all over 10 still. The square root of 100 is 10, and that negative becomes an I. Now, that's not the last step because I can simplify. These all happen to have a 10 in them, so that's your greatest common factor. I can divide these all by 10, and my solutions are negative 1 plus and minus I. So that's the answer to 2A. So you're going to move on and practice 2B yourself.